Hello everyone, my name is 𝗖𝗁 and I am the satellite projects leader at AGH University of Kraków in Poland. And today I'm going to talk about the first weeks of HyPE operations. HyPE was our first satellite launched in January, and I got to serve as the operations leader and the primary flight director. So, as I mentioned, HyPE was launched in January 14th, 2025 with Alba Orbital. It's the smallest Polish satellite to date, measuring 5 by 5 by 5 centimeters and weighing only 222 grams. It was equipped with a selfie payload, and I want to emphasize that this was our first satellite. We were a students team. So it was really an uncharted territory for us. For the mission objectives, we built everything from scratch, from the satellite to ground systems, and that is because one of our objectives was to gather the knowledge and to get to know the process of building a satellite, of sending something to space and operating it, so that now, once this mission is finished, we can focus on the more advanced missions with real scientific payloads. And these missions won't be our first mission, so we already know some of the issues that we might encounter. And we also wanted to demonstrate that a student team can do satellites and to reach out to our fellow students. So let me start with a story of the first days, actually, of the operations. So after launch, HyPE was deployed. We got first telemetry, we got first contact. It was all textbook perfect, right? And then during the commissioning phase, we encountered an error, a human error, because we miscalculated the telemetry and read 30 milliamps as 300 milliamps of power consumption. So we immediately went back to safe mode, which we knew the power consumption was okay. And doing so triggered a sensor malfunction. So this was a known issue for us, but unfortunately we didn't have time before the handoff to fix this issue. And the procedure was to initiate a restart of the satellite. So that's what we did. And then silence. Nothing. We tried pings, tried sending comments, nothing. We verified that the issue was satellite side, not ground side, because we tried pinging other satellites and they responded. So yeah, what was left is to investigate the problem and just wait, right? So during testing, we realized that there was a temperature dependency on one of our subsystems, and the radio, the timeout that we set for the radio initialization was too short for temperatures below 5 degrees Celsius. And that was something we did not test. We did test that the satellite is working in cold, but we did not test a cold start scenario. And now I want to say that we did have multiple recovery systems on board. And one of the systems that was added really hours before the handoff was a software recovery system that we called the deadman switch. And so basically the satellite, if it did not receive any valid comments for 24 hours, it restarted by itself. And so, yeah, we calculated from the telemetry that was available to us that after 2 or 3 this deadman switch triggers, we should restart in the heat. And that's exactly what happened. After 48 hours, our satellite restarted and we got the next beacons and the mission continued. There were multiple other challenges that I want to briefly touch because I believe that each of them deserves a separate paper. So the first one was our ground station issues. Because we are based in a city, the background noise is really high. and that made our RX capabilities really poor. Then this one ham radio operator reached out to us and offered his ground station as support. So we integrated his ground station into our system, and we operated like from 2 ground stations simultaneously. Then we had an issue with the satellite registration in the space track system. So basically we had an old form, and there was an old email address there. So we sent the form, and it just got lost. We realized that only after lunch, and we sent the form to the right email address then, and we got our satellite registered after like searching for it on the sky. And then we also had an issue with the deployment of the camera boom. We had this nylon string burn wire system that was supposed to hold the camera boom in place and then deploy it on orbit. So it got tangled, and that's also something that happened to us a few times. And that's why here on this photo, you can clearly see that the antennas are wrapped on top of the camera boom. And that was exactly because of that. So that's why we got to continue the mission, because the antennas deployed, and then the camera boom, it did not deploy, but it did not compromise the antennas. So for the lessons learned, the first lesson, requirements engineering. That's something we did not do. We had this like in our minds, but it was not enough. We did not trace the requirements, and we did not have this like, test plans and this acceptance criteria. And that's a lesson learned from the cold start scenario. So we did not test that. Then this issue came up. Now for our next missions, we define the tests, the criteria, and we really try to mitigate this issue. For the second lesson, the human factor management. The calculations of the power consumption, if we had automated that, we wouldn't need to go back to the safe mode, and probably the same scenario will happen like at some later point, but that's also a lesson learned still, that we need to automate data processing and the displaying of data to operators. We won't automate the decision making, of course, and that's still on the human side of things, but we can try and automate the processing and displaying of data. Then safety system designs. Here, this is not something that was an issue. That was actually something that we did well, and like I want to stress that not all lessons learned are from your mistakes. So we implemented multiple safety systems. The one that was switched that was implemented hours before handoff, and that ultimately saved our mission. Then another success on our side, the modular architecture of the ground segment, and that's what enabled us to integrate the other ground station into our system easily, because it was done like over 2 hours. So that's also because of the modular design, we were able to do that. For the administrative side of things, for the procedures, here the lesson is to always have this like checklist, and each action that you take should have a follow-up, either from you or from someone else. But if you don't get the follow-up in the defined time, then you should follow up yourself and like try to find out why did you not why you did not get the follow-up, and that would have enabled us to register the satellite before launch and not after. Then another thing that went well, redundancy in the deployment systems. So for the camera boom, in this case, the redundancy wasn't like in the hardware. It was just the ability to reinitiate the deployment procedure, but that was enough to burn the wire again and to untangle the camera and to be able to take the photo that we dreamed of. And so this was our first selfie team photo from orbit. You can barely make that, but those are our team members on the screen of the satellite. You have to trust me on this. And yeah, you can find a more detailed analysis in the paper, obviously. Here are some key takeaways from all the lessons. And this is our team just before the handoff. So like the last moment when we got to, touch our satellite. Thank you for your attention. And as it was our first mission, and now we are working on another one. If you have any experience in satellite operations, I would really appreciate that if you share that, because we learned our lessons, but we can also learn from you. So if you have any feedback for me, that'd be great. Thank you very much.